So hey everyone, welcome back to the channel. In this video we will be solving the problem sorted insert for circular linked list. So let's read the problem statement out. We are given a sorted circular linked list of length n. The task is to insert a new node in the circular list so that it remains a sorted circular linked list. Now what is a circular linked list? Basically the next node of the last node is going to be head. That is going to be the circular linked list. So for example, if our linked list is like this 1 2 4, the next of 4 is going to be 1, right? We need to insert 2 into it, so our linked list will look something like this. So this is going to be sorted and the circularity of this linked list should be maintained. Similarly, for 1479 we have to insert 5. So if we need to make it sorted, 5 should be inserted after 4. So our output is going to be 14579. Now the expected time complexity for this is going to be order of n, and the expected space complexity is going to be order of 1. So let's understand this problem in more detail. So let's say our linked list is like this 1, 4, 5 and 7, and let's say we need to insert 3, right? So in solving this problem there are some corner cases which you need to tackle, like the linked list can be null, right? So in that case what we will do, we will create a new node. Let's say we need to insert 2 into our null linked list. So we will create a 2 and we will point 2 next to 2 itself and we can return this. So this is going to be the first corner case, right? Now the second case is, let's say you are given 1, 4, 5 and 7 and you need to insert -1 into it. So since -1 is smaller than 1, right, what we will do, we will create a new node -1. We will mark this as head, right, and our heads next. Basically -1 ka next is going to be the previous head, right? So first we will mark this as like current node. Basically let's say new node, arrow next will point to head, and now our new head is going to be new node, right? So this is going to be the second corner case. Now in case we need to insert the linked list at any point of time, so what we will do, we will do it using a while loop. For that what we will do, so first of all we will mark this as temporary pointer, right? Now we will iterate till our temps next data is less than this data, right? So temp next is going to be 4, and since 4 is greater than 3, so we will stop here. Why temps next data is compared? Because we need to place the element just after the element or just before the element which is greater than that. So we will compare temp next data and it should be less than data, right? Now in this position what we will do, we will break this node, but before breaking this up we will create a new node, right? So 3 is going to be the new node. What we will do, we will point 3 is next to basically temp next. This was temp and this was temp next previously, right? So now what we will do, we will point new node next to temp next, and temp next will point to new node, because this step will create the link like this. So 3 next is going to be 4 and this will continue like this, and now we need to connect 1 to 3 as well, right? So 1 to 3 can be connected by this step, and finally we can return the head. Now this will take a order of n time, because in worst case we will be iterating throughout the linked list, right? So let's say our linked list is 1, 4, 5 and 7 and we need to insert 9 into it. So we will be iterating throughout the linked list. So the worst case time complexity for this is going to be order of n, and the space complexity for this is going to be order of 1, because we are just using two pointers, basically a new node and a temporary pointer, in order to iterate over the linked list. So the space complexity is going to be order of 1. So I hope you have understood the explanation. Let's see the code. So first of all, we have created a temporary pointer which will point to head, and we will create a new node as well because we need to insert a new node, right? Now, the first corner case, if our head is going to be null, basically we will point the head to new node and new node next will point to head, right? So let's say we are having nothing into our linked list. So, and let's say we need to insert one. So one is going to be our head and one's next is going to point to previous head, right? So that is the first step because here the element is going to be one only into the linked list. Else if let's say temps data is greater than data, because here temp is going to be head only, and this is the case where the first pointer in the linked list itself is greater than the given data, so we need to insert into the beginning. So for that, what we will do, we will iterate till the end of the linked list, right? Because the end of the linked list next is going to point to the head, and we will do these steps in order to get the sorted linked list, right? And that will be circular in nature. Now we will be iterating in the third case, and we will compare while temps next data is less than data and temps next is not equal to head, and this is a condition in order to avoid the circular linked list loop, right? We will iterate till temp is equal to temp next and new node next is going to be temp next as discussed, and temp next is point to new node, and finally we can return the head. So I hope you have understood the problem. In case if you have any doubts, write it down in the comments, like this video, and don't forget to subscribe the channel. Thanks for watching.